Good evening and welcome on another movie on alternators. I have three Bosch alternators right here. This is a 70s and 80s model alternator. This specific type is used on the BMW M70 V12. This is a 1990s up to late 1990s alternator model used on different types of BMWs. 6-cylinder M52 headed 140 amps, M60, M62 air-cooled 140 amps, and the 728 also headed air-cooled with 140 amps. I also know that Saab had this type of alternator but in a different rating, and there are some other European vehicles that had that Bosch type of alternator. Right here you see a Bosch alternator from the late 90s up to the zeros, and this is a Volvo specific type because of that strange casting, the way it's mounted to the 4 and 5 cylinders, but BMW has also used the base of this alternator. This is a 140 amp, this is a 140 amp, this is also a 140 amp. And you'll note that the alternator is getting a bit smaller. They're squeezing that amp in a smaller housing. And let me see if they're lighter. This is the Volvo 140, this is the M70 140, about the same weight. So I guess weight doesn't really matter that much. I'm going to be rebuilding these two, and I'm going to be rebuilding a Volvo unit the moment I get a new Volvo unit in. I can make somebody happy with this 140 amp. This is from my old Volvo that I sold. I put a rebuilt one that I rebuilt myself on the Volvo, took this one out, rebuilt this one too, just to keep it as a spare. Sold the Volvo, have a spare, so basically I want to get rid of this one. And I guess if I take somebody's old alternator back, I could make a YouTube movie about that too. Evolution of these alternators. This is a very nasty alternator to rebuild, for two reasons. The rectifier is very difficult to get. Now let's assume that you have a good rectifier and you don't need it. The slip ring on this alternator can be put in different positions and you need to know what you're doing. On these alternators there's only one way to put on the slip ring, and the slip ring is always fit in the right position. This alternator has a separate capacitor. The capacitor makes sure that certain frequencies are filtered out so you don't get strange complaints. These alternators have the capacitor on the rectifier bridge, so the moment you put a new rectifier on, you also have a new capacitor. Other than that, the soldering on this alternator is a bit annoying. Right here you have terminal leads that are stator terminal leads that are coming out, and you can just put your rectifier on. Your terminal lead goes through your rectifier, you cramp the rectifier, you put some solder on it and you're done. But in this one, the leads actually go around in a curve, and you need to put the rectifier on, and then you need to solder through the stator with your soldering iron. A bit annoying. I'm going to go into detail on that when I take that one apart. The moment you have an M70, you always have this type of alternator off the factory. If you have an M73, you will also have this alternator. It is possible on your M70 to convert that alternator to this alternator. There is no difference in functioning. They are both rated for about 140 amps, and they both start to work at about, let's say, 1000 RPM. That's when they actually start outputting some real amps. And at about 2,500 to 3,500 RPM, that's alternator RPM, not motor RPM, they are nearing the peak. And since that alternator pulley is about a third of your engine pulley, at idle, let's say your idle speed is 700, you are already doing 2100 RPM, so you already have a very good output from these type of alternators. If you want matching numbers and you want your car to be original, you'll have to rebuild one of these. So much for the introduction. As you see, I already blasted and painted the pulleys and this fan, so that's not really original. I just had to hurry because I've got a lot of people waiting on good stuff. I'm going to cut the movie now. If you're watching the 140 mid-90s, you will now see me taking this one apart and repairing it. If you're watching the 140 amp early 90s, you will now see me take that one apart. And in a later movie, I'll take that one apart too. So I'll be right back with one of those alternators. Okay, 140 amp mid to end 1990s model used by Saab and BMW, and probably a lot more. First thing you do is take like size 22 or 24, take that nut off, and then take your pulley off. Okay, second thing you do, you turn the alternator around, and if you're a BMW guy, you want to identify, do I have the plug or do I have the screw leads only and no plug? Because if you have only the thread for your cable clamps, you need a different rectifier and you also need a different voltage regulator. So that's something you can now identify. Then what we're going to do is take off these 3 nuts so we can get that plastic cap off. There we go. Now we can take a look at the alternator. Alright, let's see. This is pretty original because there's no soldering. They just clamped it. And let me see at that regulator. Oh, that's a weird regulator. I've never seen this before. I'm going to show you guys what I'm talking about. Hang on. Let me see. And use length to make sure that you're here. This is all small. That's all these tools are using with soft material. There we go. There we go. Regular version now. There we go. Oh, never mind, never mind. This is okay. This is okay. This is the original Bosch regulator. Brushes are pretty worn. They still have brush material, but you can see the top one is a bit worn. The regulator itself is fine, but the brushes are worn. There's one thing you can do is just replace the regulator with a good brand, or replace the brushes in the regulator, but that's extra soldering, and for that money that you need for a new regulator, they're pretty cheap. With size 8, I now take these big bolts that are holding the two housings together, and I want to be a bit careful because I can strip them quite easy. Right, so I got those screws out. And now I want to take a big flat screwdriver, find an entry point here between those two housings, and I want to gently wiggle them apart. There you go. Simple apart. Well, I'm going to I'm winding along the rectifier so you like back and gently step by step. And the reason why it doesn't want to is that the bottom of the once it's in place. Here we go. Almost got it. Almost got it. Just hold on now. You want to be careful that you don't push on that lamination because it's insulated. You just want to pry at it like this. There we go. So we've got the front housing with the front bearing and the rotor is still in place. Here you have the non-driven end bearing with a bearing cap. Here you have the slip ring. And now we have the winding and the non-driven end housing and the rectifier intact. So we are now able to salvage this rectifier and use it again if we want to. Gonna put that away. Alright. Now I want to take this bearing cap off because you can order them new for cheap money, but you can also reuse them if you can get them out in one piece. There we go. Got the bearing cap out in one piece. We can clean it and reuse it. Non-driven end bearing is actually fine. No, never mind. I didn't say that. It's making noise. So that non-driven end bearing has no more grease left and is noisy. And you can now also see the wear on the slip ring. Look at that lower slip ring. Totally worn in. The one on the top actually looks okay, but the one on the bottom is definitely nearing its end. So this alternator wouldn't have lasted another somewhat years. And now normally, to get the rotor out, you first need to take these screws out, the bolts, and then the rotor can be pushed out easily with the bearing and the bearing cap. But these can get real stuck, so you need to use fish oil on them like I just did. Wait a little bit, maybe tap on them with a hammer, put your screwdriver in, then tap with a hammer and then try to get them out. Because if you strip them, you need to start drilling and you'll damage the housing. Got that rotor out in one piece. So with the rotor on the table, we now want to get that bearing out. Then we want to destroy the slip ring. And we want to keep the wiring leads from the rotor in good condition. And that's always the tricky part. Okay, my puller is going to fit and I'm going to show you what I did. I took a super cheap supermarket brand bearing puller. And I actually grind it at the arms right here to make them very thin. Because this is what they normally look like. And this allows me to grab under these little distances from the bearing to the fan, because the normal size would never fit. And this way you don't have to buy expensive pullers for these simple bearings, because usually these simple bearings will come off. So I just need to fit the pulley nice and tight. The puller nice and tight, I'm sorry. Okay, let's see if it comes off without clamping anything. I think it's already coming off. We like that sound because that means it's coming. That should be it. The bearing came off in one piece. Let me show you basically the only downside that this slip ring method has. You see that Bosch basically has the wire coming out right here, Then they put the wire right here against this ear. This ear is part of the slip ring right there. And they somehow crimp or cramp this ear so that the wire is stuck. And they probably put some solder on it too, but I cannot see the solder. Let me see if the other one is perhaps... No, same deal. So if I put my soldering iron on here, nothing really happens. I get some smoke and I'm burning some dirt, but nothing really happens. What I need to do is get a screwdriver or a file or a knife behind this wire over here and try to cut it loose. But I risk damaging the wire, and then I risk not being able to solder the new slip ring properly. So what I normally do in this situation is I saw right here with a small saw. I keep the complete ear with the wire. Same for this side. I keep the complete ear and the wire. I then remove and destroy the slip ring completely the way I'm supposed to. I clean this with soldering acid. Same here, so it's super clean. And then I just solder the old ear with the wire to the new ear. And then I measure conductivity and I measure if I have any current going to ground. So far this method is fine, and this prevents me, or this means that I don't have to risk damaging the wire over here. So let me take out that cheap saw, and you now see me getting that ear carefully from that slip ring. And this is shit quality metal, so the saw goes through real easy. Now using pliers, I want to feel if I've got the complete ear, and I do. And when that's the case, I want to start destroying the slip ring. So I take some old tool right here, and I'm just going to destroy the slip ring top here, the copper part, to get rid of it. Okay, after hacking and breaking away at it for, let's say, 5 to 10 minutes, I got the slip ring out, I got the surface clean. I've been able to salvage the entire wire from the slip ring, so that's good, because that means I have a lot of material to work with. Now I'm going to clean this area a little bit. I'm going to sand this with Scotch-Brite so I have a nice smooth shaft surface. Going to do the same thing here, but as you can see the shaft is already pretty nice. And then we're ready to put the slip ring on. Okay, so we still got to remove that rectifier from the non-driven end housing. I've already removed one of the lead pair. I'm going to show you. This is what you want to achieve. You want that clamp to be gone and you want these leads to be free, so that when we lift the rectifier off, all the leads will stick out nicely and nothing will actually stick to the rectifier that we take off. To do so, I'm going to show you. You see that they have like a clamp here around the leads, and they've got solder in here, which you can see. And I want to use this flat screwdriver like this with a hammer to open up the clamp. And then I'm going to use these cutters simply to cut them away around the leads until they snap off from the lead. So, let me see if the camera has a nice position. I guess I'm going to put that screwdriver on top here, like I said. I'm going to take that hammer and I'm going to drive my screwdriver right through. And this is an old crappy screwdriver, so I don't care about it. Okay. Now I'm going to take the cutters and gently, carefully, I'm going to cut away at that little clamp. And I want to be careful because I do not want to damage the leads. I don't care about the clamp because the new rectifier is new ones. Let me show you how far I got already. Here you see that the clamp is coming apart, and I'm now going to cut this part away so my leads are free. There we go, that lead has come loose. I'm going to show you boys in a second. And now we've still got this other one. Okay, the other one is free too. Like I showed you guys in the beginning, I've got these leads free, and now I also have these two free. And it doesn't really matter that they're a bit damaged or that they're a bit crusty, because we're going to sand them and turn them nice after we got the rectifier off. So I'm going to continue removing all these, and I'll be back with the rectifier about ready to take off. Okay, I've got all the clamps loose, no damage to the wire, so that's good. You need to get these 3 bolts out. They hold the rectifier to the non-driven housing. Be careful with them, because as this alternator now has some age on it, they can be really stuck and you can strip them easily. So I recommend you use excessive fish oil to get them a bit less crusty. I already took the tension off these to speed up the movie a bit, so here you see me removing those 3 bolts. And now I am ready to take the rectifier off. I can already see it moving. I take a large screwdriver and I gently start prying at the rectifier. It's probably stuck on one of those leads that's kind of blocking, so you'll push that in its right position as you start wiggling. There we go. And here's our 300 something thousand kilometers old rectifier. So we have the non-driven end housing. You can see where the rectifier was, you can see where the regulator sits, and here you see the stator leads. We can now actually get the stator core out. It will be rusted shut. So we take a large screwdriver and we put it in between the edge over here and the housing. There we go. 1, 2, 3, 4. Should come out. And here we have the old stator core. This is the lamination. These are all little plates, and there is insulation between these plates. So if you want to sand and spray paint this, go ahead. But you want to sand it in this direction. You do not want to sand it crosswise, because you do not want these plates to move from each other, because that would damage the slot of the insulation between the plates that you have here. So you only want to sand this way. Non-driven and housing, bearing cap already removed. This is ready to be pearl blasted. The final part of the disassembly is removing the driven end bearing. And I already showed that the driven end bearing is being held in place by 4 bolts. And the 4 bolts are clamping this backing plate against the housing and the bearing. And that's how the bearing stays in place. Basically, you remove the 4 bolts by just unscrewing them with a Phillips head. But you always strip them because they get real tight. So you want to put a Phillips on it and you want to tap it with a hammer. And often you can get them out. But in this case, I've already tried. There's no way of getting them out. So I'm going to have to drill them out. First thing we're going to do is some fish oil. Also because it cools the drill. I've got the steel drill with like size 5 or 6. And now I gently want to drill the head off. And now I want to clean those bolts a bit. I've made a nice start with that drill. I didn't go too deep because I don't want to damage the housing. I need that housing. That's one. That's one head off. Nice. Oh, I think I already got the other one. I want to see if I can get this flat screwdriver in and get it out. Yes, I can. Yeah, there we go. Check this out. By drilling the heads, the bolts and the plate just fall right out. There we go. So here we have our alternator driven end housing with the bearing, and the backing plate just fell off by drilling off the heads. Okay, summary of the first part. All went okay. I've got my stator core out. I removed the old rectifier. All the leads are okay, and they can be worked a bit. Non-driven end housing, ready to pearl blast and paint. Driven end housing, ready to pearl blast and paint. I got the bearing cap off without any damage to the holes. I'm going to leave the bearing in on purpose, because when I pearl blast this, I risk damaging the bore where the bearing sits. I don't want that. So I'm going to clean this, pearl blast it, and then I'll push out the bearing. You'll see that in the next part. I've got my rotor out in one piece. Driven end shaft is fine. Non-driven end is cleaned. You can see that I have the leads with the old ear still on them, so I can solder the ear to ear. I've got my backing plate with the bearing right here. I'm just going to clean and reuse this. Pulley, I already spray painted the pulley a bit. Bearing cap that I'm going to reuse. And here are my new parts. New rectifier, new slip ring, new driven and non-driven end bearing, and a new voltage regulator. Okay, welcome to the assembly part of the movie. I pearl blasted both housings, put zinc on it as a primer, put a nice silver coat on it as a finish, pretty good layer. I put some dud bolts in here so that I don't damage the thread with pearl blasting, or that I don't fill it with zinc and paint. And what we're going to do now is I'm going to take that stator core out, so to show you how to prepare your stator core. Then we're going to go put the slip ring on, then we're going to put the bearing on right here. We're going to remove this bearing, put the new bearing in. We're going to put the stator core back, we're going to solder the rectifier, and then we're going to assemble the alternator. So, before I get started, let me first remove that stator core again. Here you see the stator core. I used an ultrasonic bath without any agent, so just water, to make sure that whatever agent you could use won't damage and eat away at the insulation. And if you look here, you see that I've added insulation myself. Reason for this is when I pulled the stator core from the ultrasonic bath, I could see that the copper was becoming visible through this insulation coat. So whatever happened to this alternator, some copper was becoming visible. You don't want it to happen because you don't want any power to arc to the housing. And so I put new insulation on it. The other side looks completely intact, no issues here. I also sanded all the leads. You can see that these leads are 100% clear copper. You still see a little bit of old material and from the old rectifier. This is not an issue if it sticks really well. You can just use it because it transfers electricity, so it's no problem to use it. And basically the only thing we need to do now is put this in the two housings and solder the rectifier on. Okay, you see the rotor right here with the ears. Now before we get started, I'm going to use some soldering acid on those ears so that they are clean and that any grime and debris and stuff is being cleaned by the acid. And this is the type of acid that you're not allowed to use to solder water piping because it contains that specific acid. So this is the real stuff. Now I'm going to take that new slip ring. I'm going to remove my gloves because I don't want anything that needs to carry electricity to get greasy. And my gloves are pretty greasy from all the fish oil. I've already cleaned everything, so basically we're going to push that slip ring on right here and we're going to solder those ears to that slip ring. So let me just move this wire away so my slip ring will actually fit. And let me take the slip ring and see if there is any issues. No, this is the right one. Sorry. Alright, two ways I can do this. I can use the press, which is a bit easy. I can also hammer it in, and that's actually the backyard fashion. And we're going to start tapping gently because it's possible that we're running into some kind of impurity on the shaft. And when you're tapping gently and you feel that impurity, you can actually pause and look what you're doing. So that's the sound we're looking for. That sits. Take my earphones off. I can feel that my soldering iron is already getting hotter. This is actually the old ear from the previous slip ring with the wire still on, the way they did it in the factory. Behind you have the new ear, and now I can just drop in the solder right here to connect them to each other. And this way I will not have to remove that old ear. Let me zoom out a bit. And let me get my multimeter out. Well, what do you know? The acid made the ear disappear. That's okay, because now we can just solder the wire to the ear. That's actually okay. That's the first time I see this happen, so let's see if I can also do this on the other side, carefully. Yes, I can. Oh, great. I'm surprised, because this is actually not what I expected. And I haven't worked with it like this ever before. And I've done about more than 10 of these alternators already. So that's new. Oh, in that case, we're just going to clamp the copper. No problem there. And we're just going to change our method. Good. You can see I have good connectivity and I still have that 6 ohm, which is like nothing. So now let's see if I have any connection to ground. No. 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 And on the shaft itself, I don't either. Alright, and with our slip ring in position, good conductivity between the slip rings, absolutely low conductivity between the slip rings and the rest, we can put the bearing on. So first I want to feel with my fingers if the position where the bearing sits is clean, and it is. I want to lightly oil the bearing on the inside so it doesn't rust shut so easy. I'm going to put the bearing over the slip ring. Now we need to find a suitable adapter that fits over the slip ring and that touches the bearing on the inner race, because if we would hammer on the outer race we are putting stress on the bearing. That's about ready, so let me get headphones on. Let me get the hammer again. Let's see how far we got. About, that's it. See, copper is still okay, bearing is in position, that's it. I put some motor oil on that outer race, so the motor oil will sit right here, so it won't rust so easy. And if anybody else has to remove this bearing in the future, they actually can. So using that same drive that I used to remove the bearing, we will now gently tap the bearing in. There we go. Bearing popped right in, no issue. Spins nice. So I got 4 new screws here, which I want to have copper greased before I put them in, so that the guy who's going to rebuild this in the future, if that ever happens, has an easy time of getting them out, because you saw that I had to drill. And I don't want you to drill, I'll do the drilling for you. So I'm going to drop one of those bolts in. I also want some of that copper grease to get into that tapered start right here, so it's not going to rust shut, because that's what these tapered bolts are notorious for. If you watch my 5HP24 movie, you see exactly what I'm talking about. Okay, so we've got the driven and bearing in, feels nice. Absolutely no resistance or no feeling of anything that gotten in the bearing. Got 4 new bolts. Bolts are sticking through. You can see the copper grease here to help against the rust. Next part is that we take the rotor and we lightly oil the shaft of the rotor, because we don't want anything to rust. And I'm using normal motor oil here, nothing special. Just want the to have done something on that rust protection. Remember that we need that certain ring here that sits right in front of here. Goes over there. And now we want to push the rotor through the new bearing. So we take the rotor. And we should be able to push it through, because it's not really a tight bearing fit. There we go. Rotor is in. Okay, that's the ring, and that ring is the spacer for the pulley, so that the pulley wouldn't run against the housing. We're going to put the pulley on just to make it a bit easier. I'll take it off to grease the thread later. Because with the pulley on, I can now put the alternator upside down. More easy, as you can see. I'm going to remove the dud bolts, because we are ready to put the non-driven end housing on and the winding. The next part we got to do is fit the stator, fit the non-driven end housing, and fit the rectifier. And you'll see that the regulator has to be right about there. So that means that the stator needs to go in that way. That we've got the leads going over there. So hang on, let me get that stator in. It drops right in, no issue there. And that means we now also know how we're going to put the non-driven end housing, because it can go on only one way. Now you see how the bearing sleeve, the plastic bearing sleeve, sits in the non-driven end housing, is being held by the keys, and will now go over the bearing. Let's get going. The first part of this can be done manually. And the final few millimeters you just do by putting the bolts torqued. It's got those bolt lubricated with some copper grease. Gonna close the copper grease, put it away. I'm gonna get the right socket and I'll torque them down. 1, 2, 3, 4. That's it. We've got the non-driven end housing with the bearing sleeve in position. You can now spin the alternator, and it should spin freely, and nothing should touch each other. All parts should have enough play so that you don't have anything touching each other. And since you don't have the brushes on, you will not feel any resistance. This is just bearing resistance that you're feeling. Alright, rectifier time. I'm going to use some brake cleaner to make sure they're clean because of my dirty hands. Clean, all good. I don't want these to be twisted. So we can now manually put them in the right position. That's it. Now I want to put my rectifier on. And you see the rectifier has shoes, and we want those leads to go through the shoes. And the bearing resting on the pulley now spins freely, and that actually helps me putting everything in place. I've got my leads coming through. Alright, my rectifier sits, all leads coming through. This is the final opportunity we have to check the connection of the slip ring, and I want to do this to make sure that I don't screw up. That's good. The patina that you see here on the slip ring will be wore off by the brushes. I could have used sandpaper or Scotch-Brite to get the patina off, but don't worry, if this alternator is sitting in your warehouse for about 2 weeks, you'll have new patina. So don't worry about it, the brushes are going to take care of that on the first spin. Right, so rectify in position, all leads in position. I want to use a flathead, a clean flathead, and push the leads nicely into the clamp of the rectifier. And sometimes this is not possible if you have a little bit of old rectifier material left on your leads, but let's just try to do this real nice. Okay, now I want to take those pliers and now I want to close the clamp with the pliers on the bottom so it holds them together, and on the top I really want to close. And that's okay, the solder will take care of the rest. There we go. Okay, and with the soldering done, we got to put that those rectifier bolts back on. Let's see, now we want to take the new regulator, and I want to have those two regulator bolts at the ready. Let's see, only one way this can go. Here you see the new brushes. You could replace these with hex or Torx bolts if you don't want those Phillips heads. But usually these don't really give you an issue. There we go. And now when we spin, we will feel some resistance, which is the brushes going into the slip ring. Regulator is on, 3 bolts is on. I torque these two. So now we're going to put the cap back on. Let me see. Here we go. Just like that. Now we're going to put this on. Sorry. And we don't actually use that D+, because it takes the D+ right there. So this is just a dud. There you go. And then we want to use these 3. There you go, 1, 2, 3. Don't want to over tighten them, they're just holding that cap in place. Let me hand tighten the pulley. Not going to put too much force on it. And with the pulley on, hand tight, this is our alternator. I don't know if you can hear it, but what you hear now is the slip ring and the brushes engaging each other. Other than that, we have fresh bearings, we have the stator cleaned and re-insulated some parts. We have a new slip ring on the rotor. This is basically a standard rebuild of your alternator. Hope you enjoyed this movie, hope this helps you rebuilding your BOSCH alternator. And check my channel for more alternators or steering pumps, gearboxes, whatnot. See you in the next movie.